We're gonna do something a little different in this video. I will get back to the emulator, but for now, I decided I want to make a video about interpreters and compilers. So basically, how to make your own programming language. I've been trying to learn this for a while, so I thought, like, what better way to force myself to learn something than to make a video about it. It's kind of working with the emulator, so gonna try with compilers. This is a topic I've been interested in for quite some time, and I've read like one book, like 1.5 books about it, but I feel like I have a long way to go. So this is gonna be another series. We're gonna start with a regular tree walk interpreter, and then move on to compilers, and hopefully it'll be fun and you can vibe with me as per usual. Okay, so I have a presentation this time. Back to my roots. If you're an OG fan, which those don't exist, but my first like 2 videos are PowerPoints. So we will be building a programming language, and it'll be using what's called a tree walk interpreter. So with a compiler, you are actually, let's just move on in the PowerPoint, because I will explain that in another slide. So here's like some example code of what the language will look like. We're gonna allow you to create variables. There's gonna be a few different types: numbers, strings, booleans, etc. Gonna have if statements, arrays, loops, functions, classes, and I believe that should be it as far as language features for now. But it could change as I'm going through this, so we'll see how we feel. So like, why am I doing it? Mostly just to learn. And when I did learn this the first time, it really improved my programming skills. So hopefully, if I go even farther, it'll improve them even more. And one day, I would kind of like to maybe work on like the Swift compiler or something. So I think this is a good way to start. And also, I'm bored and my life is boring. So I create problems for myself that I solve. What is a tree walk interpreter? So compilers are basically very similar. You're just translating. Compilers and interpreters are basically just a program that converts one language into another language. The difference between like a compiler and interpreter and like these definitions are up for debate, and can be a little bit wishy-washy. Compilers typically translate the code into another form of code that will be executed later, and interpreters, they compile the code, or they translate the code and then they execute them right away. So we're gonna do that for this video, but in the future I do want to create a compiler. Compilers tend to be faster than interpreters because you can optimize the code more, and you can compile it down to very low level, like assembly code or machine code. But a compiler doesn't necessarily mean that it's being compiled into assembly or machine code, but typically it is. And also, the reason we're doing an interpreter is because they're easier and they are a lot more portable. So with a compiler, if you're compiling down to a certain language, the computer has to understand that language. So if, say, you're compiling for x86 machine code or x86 assembly, you can only run that compiler on an x86 computer. So if you want to run your compiler on ARM, you will have to create a whole new version of the compiler that compiles down the um, to ARM assembly or machine code. With an interpreter, all you have to do is have the programming language installed on your computer. So this language is going to be written in Swift. So any platform that runs Swift will be able to run this compiler. So that's what makes it more portable. There's ways to get around like compilers not being portable. There's like intermediate languages you can compile to and all types of stuff, but we will get into that later. And then the tree walk part comes from we will be parsing our source code into a tree structure, and then we will walk that tree to execute each statement. Again, we will get to that later. And then why a tree walk interpreter? I think it's a very good starting point for getting into programming languages, and it's the easiest to implement to me, and it's also something I've done before once. So don't think I'm an expert or anything, but I will try to. And then as far as resources, I've been using the book Crafting Interpreters for this. It's free online. If you go to a website, there's a web version that's free. And also another one that I probably should put in this PowerPoint is the book I read is Writing an Interpreter in Go. So I will probably add that to this markdown file when I put it in the description. This will be in the description though. But let's go ahead and go to Xcode and see what we're working with. So for this, I did the same thing as the emulator where I made a Swift package and I included the Swift argument parser for parsing arguments. So all we're doing is we're taking a path to the source code file, and then we're checking if that path by the way, the path is optional, so you don't have to pass in a path. But if you do, we will get the contents of that file, put it in a source file, which would be a string with UTF-8 encoding, pass it into our scanner. I will explain what the scanner is in a second. We will scan it, and then we're just printing out the tokens that we get. So there's a few different parts to an interpreter or a compiler. You have the part that scans the source code, and then it returns an array of tokens. So a token can be like a symbol, so like a parenthesis or a colon, or it could be an identifier such as like a name, so a variable. So if we look at my PowerPoint, if we look at the code, all these things, all these like little things would be tokens. So let would be a token, that's a keyword. Another var would be a token, that would be an identifier. The string would be a token, it would be a string token, blah blah blah. One equals would be a token, but you get the point. So we just have to recognize those, and that's what the scanner is doing. And then after that, we have the parser, which creates the tree structure, and then we can execute it after that. And that's pretty much what an interpreter is, but we will get to those parts later. For now, we're just going to scan it and print out the tokens. And then if you don't pass in a path, we will hit REPL, which stands for read, evaluate, print, loop. So it's basically just a way to run the code in the terminal. So you can run code line by line. It's good for testing, or if you're just like learning how to code. So actually, if I do run this, we can take a look at the REPL. Oh, that's not right. Why is this? I didn't mean to have two things there. All right. So yeah, if we take a look at the REPL, right now I only have two tokens being recognized. But if we take a look, it recognized left paren or right paren. Yeah. So that works. If we Take a look. I actually am running tests for this one too. So right now, so far, I have we're testing for right and left parens. So source is just a string we're passing into the scanner. We try to scan it. If it fails, it'll throw an error, and then we just expect the first token to be a left paren, second token to be a right paren. And so if we take a look at the scanner, we have a class for scanner. We have a source, which is a string, and then a position, which is where we are in the source code. And then we have a line number. We have an array of tokens, and then we just have a computed variable that tells us if we're at the end of our document. And then we just initialize it, set the source, set the position to the start index, and then we run scan, and all it does is just loop until we hit the end. And each iteration we run this function, scan token. All scan token does is get the next character. It moves the position up one. So if you take a look at this advanced method, all we're doing is checking if we're at the end, and I can actually add that helper var. So we can actually say this instead of what I had before. So check that it's not at the end. If it is at the end, we're going to send the special character, which is like a null terminator. We're getting the character at the position, and then we're setting position to the position after the current one, and then we're returning that character, and that's what we get here. And then we have a big, well, it's a small switch statement now, but it will be a big switch statement. So we're checking if it's a left paren, we add a token. We just have a method here that creates a token object, and then appends it to the token array. Yeah, if it's a left token, right token. Pretty simple. Yeah, and all token is just a struct with a type and a line number. And then the token type is just an enum. So from here, we can start actually recognizing some other symbols. So a few things that I know I will need is so if let's see, we have greater than, so less than, yeah, we have equal, plus, minus, multiply, divide. I'm gonna call this slash though. Because slash doesn't always refer to the what's it called? Doesn't always refer to divide. It could also be a comment. So we're gonna say that. And a few other things we have to recognize is equal. We have greater than or equal to. We have less than or equal to. We have case double slash. Well, actually, no, we don't have a double slash. Or we don't really care that much about having an identifier for a double slash. So yeah, we have identifiers. I will worry about identifiers later though. I believe that is most of the symbols, but let me actually take a look at the crafting interpreter's book. See if I missed anything. This might be hard to see. Yeah, so, oh yeah, then we need braces too. Commas, dots, semicolons, colon. Okay, yeah, I forgot a lot of stuff. Okay. What a surprise. Okay, so I'm gonna put braces up here. So, what else? Oh yeah, dot. Gonna need that for calling things. And then also star, probably. I should say also my language differs a little bit from the one in the book. I made some changes. His requires semicolons, mine doesn't. I'm not sure what else. It's the oh, we already have star, but yeah, we're gonna change multiplication to star. Okay, so we have all this stuff. I actually do want to add one more thing to the token. So Alexim is just the actual representation of whatever is held in there. For a lot of these, it's just going to be the raw value of the int. Of the enum. But for other ones, we're going to actually need to, like, save the dynamic thing. So, like, number will be the actual number. Identifier will be the word, etc. But we'll cross that bridge when we get to it. So we got to add that in there, so that will just be goodness. I have Vim key bindings in Xcode, and sometimes I forget that I have to do Vim stuff. Anyway, so we're just gonna pass in the raw value here for the Lexeme. Okay, we're good. Let's run those tests again. See if they pass. I accidentally symbol there. Okay, so we're gonna run the tests. See if they pass. They should still pass. Correct. All right, cool. So from here, I think I'm just gonna start recognizing other ones. Oh, I forgot exclamation point. Okay, so we're gonna call that a bang. So we're gonna call that exclamation point a bang. Okay, so we're gonna start recognizing things. So we got exclamation point greater than, less than, equal. What else do we have to? Oh yeah, braces. So for the single character ones, it is pretty simple to recognize those. It gets a little bit trickier when you have to recognize ones that are multiple characters long, but it's not that hard. I will show you how to do it. All right, semicolon dot, semicolon dot colon dot colon comma. All right, I already got comma. Okay. Let me make sure I hit all of those. I believe does that cover everything? That is one character long. I believe so, actually. All right, cool. So we're just gonna do something tedious. So we have to set expectations for each one of these. So I'm gonna do this tokens type equals dot whatever. Okay, so work smart, not hard. So I'm gonna copy and paste that for each one. So this should fail. Here. Actually, I do want to also expect scanner tokens count equal 16. So, and again, it fails, obviously. Wait, oops, I didn't mean to run again. So yeah, seems like issue is, it's actually feel like this is not exactly the issue I'm expecting, but let's see. Whatever. All right. What matters is that it's failing. So let's make it pass. Oh, okay. Yeah. It failed because it threw an error. So let's go ahead and recognize all those. Okay. Hopefully that is yes. Okay, cool. We passed. All right, so now that we have all those recognized, we need to recognize the ones that are 2 characters long. So, for example, equal, equal, greater than, equal. So I'm just gonna write a new test for that. Why is it auto completing? Oh my god. Okay. All right. All right. I want to change the name of this to scan single. And then this is going to be scan multi-token. So, just going to let the source equal all the ones that could be 2 things. And then also we want to still make sure we recognize them when they have if they have a space in between them. We don't want it recognizing those, so I'm gonna do this. All right, so I can just copy and paste this part, and then we're going to also copy and paste all this is bullshit. So, oops. This one is equal. Okay. Oh, yeah. Okay. All right, we got this right. All right. Now we want to add the other one. So bang equal and okay. The reason I wasn't adding slash slash is because it really doesn't need to be a token, because I'm just gonna ignore everything after it if it shows up on a line. But I will just put it in there for testing reasons. So this should fail. All right, so we just gotta check that we have to check what the next character is for these ones. So for that, we add another helper variable, and we're just gonna call that peak. So peak will be whatever is at the current position. Since before that we advanced the before we get to this part, we've already advanced the position. So the next token will be whatever's in the current source position. So we can just say if peak equals slash, then add token slash, and then we want to advance after that, since we checked the next one. Well, actually, in this case, we're actually going to advance until the new line, since it's going to be a comment. And since advance returns something, we're going to get a warning. So we're just going to say discardable result. That just tells it that we don't care if it returns something. Okay, so yeah, for comments, we're actually going to do this while peak is not equal to the new line advance. Although, ooh, this is gonna F up my tests. I'm actually realizing. So issue here is that we have all this stuff on one line. So I'm gonna actually, for slash slash, I'm gonna put that on its own line. Let's go do this. I'm gonna add a multi-line string to make this a little bit easier. So this is a comment. Okay, so this should change nothing. So this is a comment part will be ignored. um, because we're going to advance into the new line. Because anything after the double slash will be ignored. Okay, so, all right, we got that. So we have to do that for equal. So what we're just doing here, checking if the next character is an equal. If it is, we're setting the token to equal, and then advancing the position. And if not, we're gonna set it to just equal. So it's gonna be the same thing for greater than as well. Oh. Okay, so because I don't have a space in between this, is giving me an issue. So let's just put some spaces in between these. It thought it was a greater than equal, which makes sense. Alright, so we're getting an error. Let's put a breakpoint, print the character, see that is a the character is a quotation. Why is this happening? Oh, I accidentally added an extra quotation mark there. Okay. Yeah, okay, so it's hitting a white space character, so we have to actually skip any white space. So just gonna add a helper function for that. Sorry. Is it really? Alright, so I forgot how to do this again. So let's actually take a look at the book. It actually has some little helper stuff. There you go. Okay, so we're just gonna ignore anything that is a space carriage return or a tab. So yeah, I'm not gonna add a helper function. I can just add it to the switch statement. Case. New line. So if there's a new line, then we're gonna increase the line thing. All right, so string index out of bounds. So that is an easy fix. Oops. So it's actually at the end. So yeah, if we're at the end, just print out this or return the null character if we're at the end. That may not fix it, but may have to go one before. Okay, cool. Test failing though, but that's fine. Okay, so scanner tokens equals 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm guessing the issue is... Oh, I forgot to do bang equals. Okay, so for bang equal, we're just gonna do boom and boom. Okay, I don't know what I just did. Okay, so I wasn't in insert mode. I should just turn off Vim mode. I'm not getting street cred for having Vim mode in Xcode. Alright, let's run the test again. Build failed. I think I accidentally read the declaration of bang. Oops. Alright, still failing. Cool. So, where's the issue? Okay, so it's expecting a less than here. So I literally just wrote the damn numbers out of order, I think. That's pretty silly. Okay, anyway, let's... I think I have 7 twice, don't I? Okay. Yeah, why is that? Ugh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, and then 14 because the end of token I mean, end of file token. Okay, that's why. I just miscounted. Okay. Still failed. Alright. Oh yeah, this should be 14. Okay. Boom. Alright, we're passing now. So we are able to recognize symbols and comments. From here, I would probably go to recognizing identifiers and numbers. This video is getting a little long, though, so maybe I will call it here and then hit part 2 probably sometime in the next couple days. But all right, cool. This is a start. We will continue from here. Hopefully you learned something. If not, read the damn book. The book's free. Just read it. Anyway, thank you. Thank you for watching. Like and subscribe. I need to start saying that at the beginning of the video because I be watching the retention and people stop watching way before I get to this part. But it's okay. I still love you. All right. Thank you for watching. Bye-bye.